Welcome to my channel. In this tutorial, we'll be looking at the integral of x squared divided by the square root of x squared minus 1 using the trig sub. So we can start off by letting letting x to be equal to secant theta. Take the derivative of x with respect to theta. That should be equal to secant theta tangent theta. It implies that dx is equals to secant theta tangent theta d theta. So we know x, which is secant theta. We know dx, which is secant theta tangent theta d theta. So we can plug them into our integral. So our integral, we are now taking the integral from the x world into the u world. Dx, that should be equal to the integral of x squared. X is secant theta squared divided by the square root of x squared. X is secant theta squared minus 1 times dx. Dx is secant theta tan theta d theta. So let's simplify this one out. Integral of this is secant squared theta over the square root of secant squared theta minus 1 times secant theta tangent theta d theta. The numerator simplifies out to be secant to the third power of theta tangent of theta d theta, all divided by the square root of secant squared theta minus 1. The Pythagorean identity for trig: secant squared theta is equals to 1 plus tangent squared theta. So we can find an expression for secant squared theta minus 1 just by subtracting 1 from both sides. We have secant squared theta minus 1 equal to tangent squared theta. So in place of secant squared theta minus 1, we can plug in tangent squared theta. And our integral equals to integral of secant to the third power of theta tan theta d theta all over the square root of tan squared theta. And this further simplifies to secant to the third power of theta tan theta divided by square root of tangent squared theta, just tangent theta. The theta here is further simplifies to secant to the third power of theta, the theta, because these ones will cancel out. So our original integral, which is the integral of x squared over square root of x squared minus 1 dx, is just simplified to the secant to the third power of theta, the theta. So our task now is to find the integral of secant to the third power of theta d theta. How do we do this? We can do this by further splitting the integral secant into secant theta times secant squared theta d theta. We multiply this out, we are getting back secant to the third power of theta. The reason why we are splitting this is we want to use integration by parts. Integration by parts, we can easily differentiate secant to the second power of theta. We can easily integrate, secant to the second power of theta and differentiate secant theta. The reason why we are splitting the secant to the third power into two parts. Secant squared theta, which is easily integrable, and secant theta, which can easily be differentiated. So let's use the integration by parts. Let's use integration by parts, integration by parts. So we have d and I. Which one are we differentiating? We are differentiating secant theta. We can integrate secant theta, but it is easier for us to integrate secant square theta than secant theta. So differentiating this, so this is plus, the next one is minus. Differentiating this is secant theta, tangent theta. Integrating secant square theta is just tan of theta, because when we differentiate tan theta, we are getting secant square theta. So in that case, if we are integrating secant to the second power of theta, the theta, that should just be equal to tan theta plus constant of integration. So that is how we know that the integral of secant square theta is tan theta. So we multiply the diagonal terms. When we multiply the diagonal terms, we don't need to take the integral. But when we multiply terms horizontally, we have to take the integral. That is how the integration by parts works. This is the shortcut called the DI method. So our integral of secant to the third power of theta d theta is equals to multiply secant theta and tangent theta, which is secant theta tangent theta minus, that is from here, the integral. Because we are multiplying terms horizontally, we have to take the integral, which is the integral of secant theta tangent theta times tangent theta d theta. This simplifies to secant theta tangent theta minus integral of secant theta times tangent square theta d theta. So our integral of secant to the third power of theta d theta is equals to secant theta tangent of theta minus integral of secant theta times tan square theta is the same as secant square theta minus 1. That is from the Pythagorean identity of trigs, the theta. Does this simplify to secant to the third power of theta d theta is equals to secant theta tangent theta minus integral of secant theta. So we distribute the secant. We have secant to the third power of theta minus secant theta, all the theta. Integral of secant to the third power of theta d theta is equals to secant theta tangent theta minus integral of secant to the third power of theta d theta plus the integral of secant theta d theta. So there's a pattern here. There's secant to the third power of theta here. There's secant to the third power of theta here. So we can just add that on both sides. So we add integral of secant to the third power of theta d theta. Do the same thing to the left hand side. Integral of secant to the third power of theta d theta. And some things will cancel out nicely. Next, we add this secant to the third power of theta d theta plus secant to the third power of theta d theta. That should be 2 times the secant, the integral of the secant to the third power of theta d theta. That should be equal to secant theta tangent theta plus the integral of secant theta d theta. These terms will cancel out. Next is to divide by 2, divide both sides by 2. So that should be the integral of secant to the third power of theta d theta equal to 1/2 secant theta tangent theta plus 1/2 the integral of secant theta d theta. However, the integral of secant theta d theta is just a natural logarithm of the absolute value of tangent theta plus secant theta. Let me just be consistent by bringing in the secant first. Secant theta plus tangent theta. This is the integral of secant theta. So we can now put everything together. We have secant to the third power of theta d theta. The integral is 1/2 secant theta tangent of theta plus 1/2 natural logarithm of the absolute value of secant theta plus tangent of the angle theta. So this is secant to the third power of theta. But we know that our original integral, which we wanted, which is integral of x squared over the square root of x squared minus 1 dx, this was reduced to integral of secant to the third power of theta d theta. And we have to evaluate that in terms of x. Secant theta tangent theta plus 1/2 natural logarithm of secant theta plus tangent theta. But we know that our substitution, if we can go up a little bit, we used x to be equal to secant theta. So x was equal to secant theta. But we know that x was equal to secant theta. So that means that secant theta is just equal to x over 1. So we can draw a right triangle. Put our angle here, theta. This is the opposite side. Opposite side. This is the right angle. Secant is hypotenuse over adjacent. The side always opposite to the right angle is the hypotenuse. So this place is x. Secant is hypotenuse over adjacent. So adjacent is 1. This line is adjacent to the angle theta. And this is the opposite. We can call that A, because we know that secant theta is equals to hypotenuse over adjacent. Now let's use the Pythagorean identity to find the length of A. So x squared, which is the square of the hypotenuse, is equal to the sum of squares of the other sides plus 1 squared. So that implies that A squared is equals to x squared minus 1. That implies that A is equal to the square root of x squared minus 1. So the length here is square root of x squared minus 1. So we know secant theta, which is x. We don't know tangent theta. We are yet to find that. So we can find that from here. And we know that tan of the angle theta is equals to opposite over adjacent. So tan of the angle theta is equals to opposite, which we just find out to be the square root of x squared minus 1 divided by 1, which is the square root of x squared minus 1. So we have found tan of theta in terms of x, which is the square root of x squared minus 1. We can plug that into our integral in terms of theta, and we get our final integral. So that means that the integral of x squared over the square root of x squared minus 1 dx should be equal to 1/2 secant theta tangent theta. 1/2 secant theta. Secant theta is x. Tangent theta is square root of x squared minus 1 plus 1/2 natural logarithm of secant squared plus 1/2 natural logarithm of the absolute value of secant theta. secant theta is x plus tangent theta is square root of x squared minus 1 plus c. And this is the value of this integral. So we can find that if you want to verify that this answer is really the correct answer, we can just take the derivative of this one, 1/2 x square root of x squared minus 1 plus 1/2 natural logarithm of the absolute value of x plus square root of x squared minus 1 plus c. When we do this, we should be able to arrive at this rational function x squared minus 1. Yeah, so this is the value of our integral. So if you find this video helpful, make sure to hit the like button, subscribe to my channel, hit the notification bell for more content like this. Thank you so much for watching, and I will see you in the next one. Bye bye.